In this video, we will be looking at solving simultaneous equations. Now, the more common way to solve simultaneous equations is through the elimination method. I'll make a separate video on other methods to solving simultaneous equations, but this is the one that's most common that you will probably learn in school before anything. Now, simultaneous equations have two unknown variables, or letters, the x and the y in this case. And because of this, we cannot solve them like normal equations. These equations have a specific solution such that a certain x and a certain y satisfy both equations at the same time. Hence, they are called simultaneous equations. Now, if we have a look at this first example, when it comes to solving simultaneous equations through the elimination method, we want to eliminate one of the variables. And to do this, we need to make one of the variables the same. So in this case, we have 3x and 3x, so they are the same here. There will be times where they're not the same, and I will show you in the next example how to fix that. Once they are the same, we simply subtract one equation from the other. So in this case, we will subtract the bottom equation from the top equation in this order. So 3x minus 3x gives 0. That's the whole point. We want to eliminate that x. 2y subtracted y gives us y. And 20 minus 16 is 4. So we can get rid of this, and we're left with y equals 4. So we know that is one of our solutions. Now, to work out the other solution, it involves a bit of substitution. So if we pick one of our equations, let's pick this one here, we can rewrite that. But rather than having y, we know that y is 4. So we can write 3x plus 4 equals 16. And again, we only have one variable in this equation now, so we can solve it like a regular equation. So if we subtract 4 from both sides, we have 12, and divide that by 3, x is 4. So in this case, x is 4 and y is 4. You can double check this by substituting them into the other equation, and you will find that 3 times 4 is 12, 2 times 4 is 8, together they do in fact make 20. So that is correct. Okay, like I said before, what if the equations do not have a variable that is the same straight off the start? What you can do, just like with fractions and other things like that, whatever you do to one side, you have to do to the other. So, rather than just making one of them, so for example, we want to make this one the same because 1y can be multiplied by 3 to easily fit into 3y. Whereas if you were to pick the x's, you'd have to make them both 12, and that involves manipulating both the equations, which is just more work than we need to do. So we're not going to do it. So if we multiply this equation here by 3, and this one stays the same, we are going to have 12x plus 3y equals 78. And on the bottom, that is going to stay the same, 3x plus 3y equals 33. Now, just like the first example, we can subtract those from each other. 12x, take away 3x, leaves us with 9x. The y's will cancel because we're subtracting them. And 78 minus 33 gives us 45. Now, we don't have any extra terms here. Makes it nice and easy. We can simply divide by 9. And that gives us 5. So we've worked out our x variable is 5. And again, you can pick either equation 1 or 2 to substitute this x into it to work out the y variable. So if we pick equation number 1, we're going to have 4 lots of 5 plus y equals 26. Now 4 times 5 is 20, plus y equals 26. Fairly self-explanatory here. If we subtract 20 from both sides, or you can just look at it, you can see y is equal to 6. And again, in your own time, I will let you substitute those numbers back into the other equation just to check that they are correct. But that is the end of that question. Now, one thing I want to add is when it comes to choosing whether you add or subtract the equations from each other, if the variable that you want to eliminate has one positive and one negative, you will add them, because these will counteract each other and it will eliminate the variable. It is complete coincidence that I have chosen two questions that both involve negatives. But for example, let's say this positive 3 here was a negative. If we subtract those from each other, it's just going to end up being 6y rather than 0. If I change that negative to a positive, you can see that these two here will cancel each other out. So it's not always going to be a negative, but it just so happens that this example is. Thank you very much for watching, and I hope that helped.